In this lesson, we're going to be graphing the sine and cosine curves. Sine and cosine, those are both periodic functions. If the values of a function are the same for each given interval of the domain, the function is said to be periodic, where the interval is the period of the function. So here we have the graph of a sine curve. The period for all sine curves is 2 pi. The domain is all real numbers. The range is from -1 to +1. The x-intercepts occur at all values of pi times n, where n is an integer. And the y-intercept is 0. The maximum of values occur at pi over 2 plus 2 pi n, where n is also an integer. And the minimum values occur at 3 pi over 2 plus 2 pi n, again where n is an integer. For cosine, cosine is pretty much the same as the sine curve, except it's shifted one way or the other by pi over 2. So it's the same as a sine curve, it's just shifted pi over 2 units. So the period is still 2 pi, the domain is still all real numbers, the range is still from -1 to 1. However, now the x-intercept, again, it's shifted by pi over 2, so the x-intercept occur at pi over 2 plus pi n, where n is an integer. The y-intercept now is 1, and the maximum value occurs at pi times n, where n is an even integer. And the minimum values occur at pi times n, where n is an odd integer. Now the amplitude of a function, it is the coefficient for the sine or cosine function. So the number that is in front of sine or cosine, the absolute value of that number is the amplitude. And the period is determined by dividing 2 pi by the value that is in front of your variable. So if you have say sine of, if k was 2, sine of 2 theta, to find the period, we would divide 2 pi by the number in front of our variable theta. And notice that k is always greater than 0. It's a positive value. And remember from previous studies that whenever we have values inside of the parentheses, we're typically doing the opposite. As far as translation, if it's a positive, we're adding a positive value to our variable inside the parentheses. If it's a positive value that we're adding a value, then we're going to move in the negative direction. If we're subtracting a value inside the parentheses, we're going to be moving in the positive direction, horizontally. Same is true for stretching and shrinking. Whenever the value of k inside the parentheses, if that's a number that's greater than 1, then you're going to be shrinking horizontally. If that value is a number between 0 and 1, we're going to be stretching it horizontally. And then outside the parentheses, whenever we add a value, that will cause the graph to translate vertically. So if you're adding something outside the parentheses, that will move the graph up. If you're subtracting something outside the parentheses, it will move it down. So, and in this example, we want to identify some key parts, characteristics of this curve. We can see that the 4 in front of cosine tells us what the amplitude is, the absolute value. The absolute value of 4 is just 4. And the period would be 2 pi divided by the number in front of theta. 360 divided by 1 is still just 360, so the period is still 360 degrees or 2 pi radian. The phase shift, we want to take the entire quantity inside of the parentheses and just set it equal to 0. When we do that, we get theta equals negative 330. So that tells us that it's going to be shifted 330 degrees to the left. And then we are adding 1 outside the parentheses, so that would indicate a shift up of 1 unit. If we were to graph that function, notice that the x-axis is in degrees, not radians for this problem. This is what the basic cosine, the parent cosine curve looks like. And then if we were to multiply that by 4, we have an amplitude of 4. So that makes the maximum value 4, the minimum value negative 4. And then if we're adding 1 outside the parentheses, so that would shift this green graph up 1 unit. And then the quantity inside the parentheses would shift it to the left at 330 degrees. Now for this one, notice that we are using radian measures for this one. So the amplitude is going to be the absolute value of the number in front of sine. Absolute value of 4 is 4. And now for the period, we've got theta divided by 4, which is the same thing as 1/4 theta. So we're going to divide 2 pi by 1/4. When we do that, we get 8 pi. So the period for this sine curve is going to be 8 pi. And then the phase shift we can determine by setting the entire quantity in the parentheses equal to 0. When we do that, we get theta over 4 equals negative 3 pi over 4, and then multiply both sides by 4. That'll give us negative 3 pi. That'll tell us that the basic sine curve is being shifted 3 pi units to the left. And then for the vertical shift, we are going to use that 2. 2 is being added to that sine function. So that 2 is going to tell us that it's going to be shifted 2 units up. For the vertical shift, we look at the vertical shrink or stretch. It's going to be the amplitude that's going to tell us what's happening there. So since the amplitude is 4, that's going to tell us that there's going to be a stretch by a factor of 4. As far as the horizontal shrink or stretch, again, we want to take that number that's in front of our variable, so 1/4 theta. All right, so 1/4, we just want to take the reciprocal of that value. So it's going to be, typically, if you're multiplying by a fraction, you would think that it would make it smaller. But again, everything inside the parentheses, it's the opposite. So instead of making it, reducing it by 1/4, it's actually stretching it horizontally by a factor of 4. And then we want to, again, as far as the translation, left and right, up and down, we can just refer to the phase shift. So translate, it's going to be shifted to the left 3 pi units. And then as far as the vertical translation, it's going to be shifted up 2 units. And then for the sine curve, this is what the basic sine curve looks like the following. If it has an amplitude of 4, then it's going to be vertically stretched by a factor of 4. So the new maximum will be 4, new minimum will be negative 4. And it's going to be stretched horizontally by a factor of 4 because we are multiplying our variable by 1/4. So again, that's going to stretch it by a factor of 4. So where the maximum was initially at pi over 2, that position is now located at 2 pi.